Hello everyone, this is Samarian, and this is part 2 of the Advanced Programming in the Toy Box series I've begun. And in this video we're going to be talking a whole lot about counters, because counters are a great thing you can be using for programming in the Toy Box. They're basically, in programming there's a lot of values that are used in programming, a lot of integers and things like that, and counters are what let you basically do the same thing to a more simplistic type of. You can't be quite as advanced with it, but with a few clever tricks, you can do some interesting things with counters. So what we're going to do is we're actually going to make ourselves a little challenge here, and it's going to run almost completely on counters. There may be a logic gate here or there, but it's going to be using the power of counters in various ways. So what we're going to be building is we are going to be building basically a, let's call it a survival type game, where we're going to use this counter right here, and it's going to be counting down constantly, and once it hits the value of 0, the game is going to end. Now the way to keep the counter bouncing back up is we're going to have enemies spawning, and we're going to be using counters to control that as well. And every time you defeat an enemy, the counter is going to go up a little bit. So counters have a few properties in them. The target count is usually the most important. This is basically if I set this target count to, let's say, 5. When the counter reaches 5, it's going to send a target reached message. In programming terminology, this is basically, if we call this counter A, then what we would create at this point is a if-then statement that says if A equals 5, then target reached. But this first counter we're not going to be using target reached as much in. This counter is going to be the only one we're going to be wanting to show the entire time. So we're going to keep the visible display on. When I'm doing advanced stuff with counters, I usually have the visible display turned off. Now we're going to use this option right here for this one counter. This isn't an option a lot of people use a lot of the time, but what it is a great way to set your counter. And I'm going to set it to 60. It's a great way to set your counter so that all you have to do is send a reset message and your counter will be at that value instead of trying to send a whole bunch of increment messages to it to get it to the value 60. If I set this value to 60 and I send a reset to this counter, it will get to the value of 60 instantly. So that's one thing we're going to do is we're going to make a logic connection. We're going to be using this challenge maker for the whole thing. And when invite's accepted, which is the first message a challenge maker sends out, we're going to reset this counter to set it to the value of 60. And we're going to be hitting it a bit later, but first we're going to make our enemy generation. And what we're going to be doing is we're going to use 2 counters for this. And what we want to do, here let me find the enemy generator quick, is we want to have it set so that we're always going to have 5 enemies up on the screen. And we're going to use 2 counters to do that. And what we're basically going to do is, let's call this counter A and this one B. Now in regular programming, I would be able to say if A equals 5, then stop generating enemies. If A is less than 5, then start generating enemies. But you can't do more than 1 target count in a counter. So the way around that is to use multiple counters, and every single thing you do in the toy box that will increment or decrement one of the counters, you have to make sure it does the same to every other counter by the same amount. So all the counters are always the exact same count. So I'm going to turn off the visible display on both of these. And how I'm going to get around the fact that I can't set a multiple values in the counter is I'm basically going to program it so that if A equals 5, I'm going to stop generating enemies. But if B equals 4, I'm going to start generating enemies. So I can't say less than 5, but I can go 1 count down from 5. And since we're only going to be incrementing or decrementing by 1 for this setup, that means that if we are if we start the game, we're generating enemies, we're going to hit a target count of 4 first, which is going to say keep generating enemies. And the way I'm going to be generating these enemies is I'm going to use a repeater to do that. And a repeater will just send a signal once every however long you set it to. So I'm going to set it to once every second. It's going to send out a signal. And every time it sends out a signal, every time it repeats, I'm going to generate an enemy. And let's just pick something not too tough. Let's go with Kyozo Blade. Why not? So that's all that is. Every time this guy repeats, we're going to generate an enemy. So how are we going to track all this with counters? Well, we're going to set it up so that the enemy generator, when it generates an enemy, is going to increment each of these counters by 1. So every time it generates an enemy, it sends a +1 to both counters. And every time an enemy is defeated, we want to decrease the value of this counter by 1. Like that. So every time it generates, it's going to add. Every time you defeat one, it's going to subtract. So this counter is set to 5. When we reach the count of 5, we want to stop generating enemies. So what we're going to do is, when we reach the target count of 5, or if A equals 5, we're going to turn that repeater off, not on. And if B equals 4, which is its target reached, we're going to turn this repeater back on. So what it's going to do is it's constantly going to be giving us 5 enemies. When we get below 5, it'll start generating more, and when we hit 5 again, it'll stop generating them. So we want to be able to do one other thing here. When an enemy is defeated, we want to increase this counter, which is going to be counting down the whole time. We want to give it a bit of a value boost, and we're going to say by 5. So if we defeat an enemy, this counter will go up by 5. Now another thing we want to do is this counter, which is going to be reset to a value of 60 and is going to be counting down, we want to set it up so that when a 0 is reached, and this is the nice thing about all counters, is they can technically track 2 different numbers. They can track the target count that you set it to, which will send a target reached message, or they can send a 0 reached if they hit the value of 0. So we are going to say when 0 is reached, we complete the game. The challenge is over. So that just leaves us one more thing we want to set up with a counter, and I'm trying to use counters in various different ways so you can see how powerful they can be. And what we're going to do is I designed this little piece of logic in 2.0 because time delayers, these guys here, in 2.0 you could only set them to the lowest speed of 1 second. Now you can set them to a quarter second, which is much better. But I got very used to using my own way of designing my own, basically my own time delayer. And the beauty about this time delayer circuit that we have here, couldn't find a counter for some reason, is that it also works like a timer where I can just turn it off and it won't fire out a signal. A time delayer is great, but once you send a signal to it, it is going to fire it off no matter what. You can't tell it, whoa, don't do anything. So what we're going to design here is we're going to be using a few different options on this counter here. We're going to set its target count to 5, and we're going to turn off the visible display. And we're going to use this bottom option, which is reset on target reached. So every time this counter sends out a target reached message, we're just going to have it automatically reset to its reset value, which is by default 0. So this counter is going to clear itself every time it hits the target reach of 5. So we're going to hook up 2 connections from the logic gate here. We're going to say when the logic gate is opened, increment by 1. And we're also going to say an output from the logic gate is going to increment this counter by 1. So how we start the circuit is we open this logic gate, which increases the count of this counter, and we're going to use another option from a counter, which is count changed. So every time the value of that counter changes at all, it will send a message. So we're going to say every time your count changes, input to this logic gate. So we basically created a loop right here that's going to keep going and going, and every 5 cycles of this loop, because the target reach is set, or target count is set to 5, we're going to send out a target reached message. And it'll keep looping and looping again and again. And the way we stop the circuit is we send a close to this logic gate, because the output of this logic gate is also incrementing this counter, but the input blocked is set to nothing. So if I close this logic gate, the whole loop stops. And then when I open it again, because the open logic is incrementing this counter, the whole thing starts all over again. So what we're going to do is, the advantage of this loop is it's happening very, 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 very quickly. So what I'm going to say is every time this counter reaches a count of 5, we are going to decrement this counter by 1. Doesn't seem like a lot, but you're going to see when I start this challenge up, that counter is actually going to start going down at a fairly decent rate. Actually thinking about it, it's going to go down a lot faster than I want it to. So I'm actually going to set this target count to 10. Because from testing in a basically empty toy box before, I found a target count of 10 in this type of circuit equals about a quarter second time to layer. So every quarter second, this count is going to go down by 1. So every second, this count should go down by about 4. So we've got that set up. Now to start that circuit, we're going to say when the challenge starts, we're going to open this logic gate, which starts the whole loop going, and it's going to start subtracting this guy, which we have set to the count of 60 by resetting it with invites accepted. Now when we start, we also want to start spawning enemies. So we're going to turn this repeater on, which is generating enemies here, which is controlling the value of these 2 counters. And we also have it set up so that if you defeat an enemy, this counter is going to go up a bit. So let's see. Now, when the game ends, when it's all over, I want to close this logic gate to stop this loop from happening. And I also, when the game ends, just to make things nice and tidy, I'm going to remove all the enemies, and I'm going to turn off this repeater. And to be safe, in case you want this game to be replayable, I'm going to reset both of these counters. And then we're going to step on that challenge maker and see what happens. So we've got our count of 60 from the reset right away. And when the game starts, that count should start going down at a fairly quick rate. And we're starting to spawn enemies. And let's make sure that the... Oh, hey, that's not very nice. What is this? Oof, that count's going down. Oh, there we go. My count went up a bit. And you see the enemy generator keeps generating me more enemies, so that I always have 5 of them on the screen. Oh, I think I'm about to die. Yeah, and there we go. The counter is over. And the game is over. So that's how we used 4 counters to actually develop a pretty clever piece of gameplay here. And we'll start it again, and everything should work perfectly fine because we set it up so when the game ends, we reset all the important logic. And these guys start spawning again. We've got 1, 2, 3, 4. We've got 5 of them, just like we're supposed to. And every time we defeat one, another one appears. And there we go, I ran out of time again. So as you can see, counters can actually be used to track a whole lot of things in the toy box, and they're incredibly useful. And they're really important when you want to start doing some advanced programming like this. So again, this has been the second part of the advanced programming series. This is Sumerian, and I hope this information has been helpful to you.